Are we doing quiz review? Well, you can call it a quiz review or no, because I'm not doing this for the quiz. It was in my original tutorial plan, but you can call it a quiz review because it will be on your test as well. It's like a coincidence. I'm kind of worried about this quiz, to be honest. Just have a weird feeling. Like it's the end. I have a really weird feeling. Have you seen a quiz yet? No, I haven't seen a quiz yet. Usually they send the quiz to me a few hours before your quiz, so I will see it tomorrow afternoon. But I just have a weird feeling that they'll give you something weird. I don't know. Just weird feeling. Weird in good or weird in bad. I guess towards the bad side. Like I'm not saying I think it's gonna be hard or something. I just feel like they'll give you something you've never seen before. The reason I feel like this is because you guys are showing too much. Like the professor know that you think inductions are basically following certain algorithm. So I feel like they'll surprise you. that's what I feel. I feel like they're gonna surprise you because I see people keep talking about people keep talking about how induction is just following certain algorithm, but it's actually not. It's just the questions you've seen look like this. But in that case, I feel like they can surprise you easily. They can give you a question that does not follow any of the algorithm you've ever seen, and you're gonna freak out. It's probably not gonna be hard, but it's gonna be surprising. Can you drop it now? The deadline was yesterday. Drop deadline was yesterday. It's over. It's today. It's today, isn't it? Yesterday? Isn't? Hold on, let me see. Oh, it's today. Oh my god. Drop deadline is today. Cause I keep thinking today is Thursday. It's Wednesday. Drop deadline is on Wednesday. Oh, I'm not encouraging you to drop this course, guys. Please don't get me wrong. I am not encouraging you to drop this course. It's just I'm saying this because I don't want you to think all induction questions are the same, because they are not. Okay, that's what I meant. They are actually not all the same. So don't think they're all the same. You need to use your brain. Don't follow something without your brain, then you will do bad. Okay, use your brain. Do you have an idea of the cutoff of CS for 102 this year? I have no idea. I think it will also depend on how people are doing next semester. And since next semester is in person, we really do not know how people will do. Because, well, for the past 2 years are pretty much online. So I don't know how people will do when we go back to normal, go back to in person. So I really don't know. Let's see. Crossing fingers that everyone fail next semester. Wow, that's mean. That's really mean. Go back. Someone said, can you give us a surprising example of induction question? Let me think about it. Let me think about it. Oh, one year, the final exam, they asked them something like, proving a number is irrational. Yeah, it was something like this, if I remember correctly. Okay. Those are my notes from. By the way, I do not have time to do all the questions, so we'll do 2 of them out of 4. Okay, I did the other 2 in my other tutorial, so they will be recorded. And let me just write something down. So for example, why it suddenly turned this color? Okay, there we go. So I remember one final exam, they had something like, so many messages. Let me see what's going on here. Okay, let me see. Let me see if I remember. It was something like x is a sequence. I hope I remember it correctly. Defined by. So it's proving something is a rational number. So it was something like x1 equals to square root of 2 and xn plus 1 equals to square root of 2 plus xn. For let me think about it, because I don't remember the exact question. It just let me think about which my n will be. Is it greater than or equal to 1 or 2? 2 plus square root of 2 is still irrational, so it's greater than or equal to 1. And then prove xn is irrational for all n greater than or equal to 1. I think it was something like this. So this is not something you've seen before. It's still induction question, but it's kind of surprising. At least I remember the students who were taking this exam, they got surprised. So this is something, something that could be just an example. So there are many other examples. For example, let me think. I don't have many examples. For example, they can combine injectivity, surjectivity, bijectivity with induction and ask you to prove something. Okay, don't ask me an example. I don't have an example, but I'm just saying that's a possibility. Because you're being tested on injective, surjective, bijective, and induction. They can give you something like that. Combine those 2 together and give you a question that can be surprising. What else? They can also give you a strong induction that requires many base cases that you probably never seen it before as well. So there are many things. Mind giving us an example using induction bijection? I don't have many examples, guys. It's really hard to come up with the examples. Is quiz 4 easier than quiz 3 based on past? I don't think there is a pattern based on my experience in 102. Each year is different. Every year is different. Anyway, yeah, this is just an example that I think they can surprise you with something like this. There are many things. For example, this one is kind of surprising as well. Actually, not really, because the problems of question is similar to this. So it should not be a surprise, but you should know how to do those questions as well. But anyway, go back. A strong induction. So let's talk about this. Never mind. Strong induction. So I'm not erasing those because we will just talk about those. The principle of mathematical strong induction. This one is really similar to induction. Whoever sneezed, that was my boyfriend. You can hear him? Didn't know. Huh, interesting. That means whatever he says, you can hear him. Just the sneeze. He only sneezed. He's working right now. not talking. We're not even in the same room. You thought it was someone in the Zoom. No. No, it was from my end. Well, I didn't know. That means whenever my cats meow, you can hear them as well. And when my dog barks, you can hear him as well. Wow. Okay. Anyway, back to induction, strong induction. So here, look at this. Look at what I highlighted. If you compare the principle of induction and strong induction, you will see that the only difference is this part. For induction, they only have pk here. For strong induction, you have P1, P2, P3, P4, all the way to Pk. That's the difference. Okay, that is the difference. And door closing and opening. Oh my God, but that was so far away from us. This is making me anxious because you can hear everything happening in my place. Anyway, so strong induction means you have a stronger hypothesis. So compare those two, you see that back to domino example, induction means if we knock over the first one, and for any k you pick, so for any k domino you pick, if we knock over this one, the next one's gonna fall as well, then everything's gonna fall. That's induction. Strong induction is if the first one's gonna fall, and if you pick a random k here, everything between the first one and the kth one will fall, cause the next one gonna fall. So that's the difference. The difference is you have a stronger hypothesis. Instead of pk, you assume for everything between 1 and k. Okay, so that is your strong induction. When do I use this? Here. When do I use strong induction? Whenever you need information that's before pk. So induction only gives you information about pk, but sometimes you need more. You need information about pk minus 1, pk minus 2, or even pk minus 6, 7, something like that. Okay, so that is when you need strong induction. Any questions so far? Does that make sense? The difference between induction and strong induction? I think someone DM'd me, but I can't. I don't know where they go. Too many messages. Yeah, true strong induction is when you need information before PM. So for example, recursive sequence, you might need information about AM minus 1, AM minus 2, AM minus 3. Then AM minus 2 is before. That's PK minus 1, yeah. So that's before PK and so on. So if you need information before this one, then you need strong induction, because induction does not give you any information before this domino. You need strong induction to give you the information before this domino, basically. Okay, so that is a main difference between induction and strong induction. Here is another thing I talked about in my last tutorial. I'm going to talk about it again. For strong induction, sometimes we need more than one base case. For recursion, you do not think like that, because recursion, it depends on how many terms you're depending on. For example, if your recursive sequence only depends on AM minus 1, then you don't even need strong induction, because that you can solve it using normal induction, because you only need the term before our term. But if you need more than one terms before it, then you need strong induction. Yeah, so it's not like, oh, if you say recursion, it's definitely strong induction. Not necessarily. It really depends on how many terms you have in your recursive definition. So how do you need the information before PK? Yeah, so go back to my plan. So I was gonna say what? Base case. So a lot of you know that for a strong induction, a lot of time we need more than one base case. Why is that? Why is that? Why do you need more than one base case? It actually depends on your inductive step. Okay, when you do your inductive step, you will figure out how many base cases you need. For example, let's do an example. 2. So I want you to use strong induction to prove that someone asked you, would you lose mark if we use strong induction instead of induction? No. But if you need strong induction and you use the induction, then you will lose mark. Back to this. Example 2. So they asked you to use strong induction to prove that any integer greater than or equal to 12 can be written as sum of 4s and 5s. How do we show this? So proof. When I do those type of questions, I usually do base case after. So I'm gonna leave base case here. Because now I do not know how many base case I need. I really don't know. So I'm gonna leave it here. I'm gonna start with my IH. So IH, I'm gonna suppose 12, right? 12, 13, all the way to K. Can be written as sums of 4s and 5s. For some K in natural number, and I need something more that I don't know for now. Okay, I need K to be greater than or equal to a number, which I do not know so far. Okay, so I'm gonna leave it like this. Because this part and this part, I can only know from my from my inductive step. Once I start my inductive step, I know how many base cases I need, and I know what my K needs to be. So let's do the inductive step. Inductive step or induction. So I need to prove, remember, we need to prove K plus 1 can be written as sum of 4s and 5s. Right? This is what I need. And remember, we always need to use your IH. So IH, I know before K, they can all be written as 4 and 5s. So I'm gonna consider what? I'm gonna consider K plus 1 minus 4. Why do I do that? Because if I use K plus 1 minus 4, then it's gonna be less than K, right? This is gonna be less than K, so it can be covered by my IH. However, I know it's gonna be less than K for sure, but I also need this to be greater than or equal to 12. Does that make sense? Because my IH only cover from 12 to K, so this number needs to be less than 4 and greater than or equal to 12. Does that make sense? Yes. So this is greater than or equal to 12. And here is how I know what my k is and how many base cases I need. So here's my rough work. If this is greater than or equal to 12, then k is greater than or equal to what? Anyone? K is greater than or equal to what? 15, right? So this is how we got k needs to be greater than or equal to 15. Okay, so I got k is greater than or equal to 15 here. This is gonna tell me my base cases as well. So since k needs to be greater than or equal to 15, we know we are starting with 12. So your base case will be 12, 13, 14, till 15. So you would have 4 base cases. Does that make sense? And one of you said, why did you pick 4 instead of 5? I can pick 5 as well. But if I pick 5, then I need 6 base cases and I'm lazy to write another one. So I always pick the smaller one. So I have less base cases. Why don't you pick 3? If I pick 3, remember the reason I pick 4 here is because I can later add it back. So I can have k plus 1 equals to whatever I have before is a sum of 4s and 5s plus a 4. So it's still sum of 4s and 5s. But if you add 3, then it's not necessarily 4 and 5s only anymore. Does that make sense? Yes, okay, cool. So now, based on here, we got this. So let's go back and finish my base case. So I need 12, 13, 14, 15. So let's do them. 12 equals to 4 plus 4 plus 4. And this is 4 plus 4 plus 5. This is 4 plus 5 plus 5. This is 4 plus, no, 5 plus 5 plus 5. Okay, so base case is down. Inductive hypothesis is also down. Now go back to induction. Consider this, is this greater than 12? Because since k is greater than or equal to 15. Since it's greater than or equal to 12, less than, it's gonna be less than k. By IH, we know that k plus 1 minus 4 can be written as sum of 4s and 5s. Right? So this is what we have. And now we know this can be written as 4s and 5s. And this equals to what? K plus 1 equals to 4 plus sums of 4s and, this is bad. Let's give it a name. Can be written as sum of 4s and 5, call it S. So which means S equals to k plus 1 minus 4. Then k plus 1 equals to S plus 4, which is also sums of 3s and 4s and 5s. So that's it. That's your induction. Okay. In the induction step, where did the k greater? Well, because you want this to be in between 12 and k, right? Remember? You don't know how that proves 5 because your S is the sum of 4s and 5s. So you're just adding another 4 to it, and it's still 4s and 5s. Does that make sense? Okay, cool. I hope it makes sense. If it doesn't, there's nothing I can do. This is the best I can do. Someone asked, can we write k plus 1 minus 4 and minus 5 and equals to 0? Well, you don't necessarily have the same number of 4s and 5s. That's the first thing. The second thing, that's what you need to prove. You cannot start with what you need to prove. In different way, yeah, you can use 5 here. So here you can use 5. Then everything's gonna change, because if you use 5 here, this is gonna be different, and you have more base cases. You have 16 as well, because this is gonna be 16, and this is 5 and 5. You add it to 5. It's the same thing. Did they using 2 variables? So they added how many? So they did how many 4s and 5s we have, something like that, right? Yeah, I knew it. I knew it. I mean, you could, but I don't want to. I could, but I don't want to. This is good.
I had a question. So when you say k plus 1
12
equals,
because you're proving that greater than or equal to 12. 15 because we got it from here. Remember, I erased it, but it doesn't mean. Did you write 5 equals to k plus 1 minus 4? No, this is S. Oh, this is S. Sorry, this is not. Oh, let's call it, because it's sum. I was thinking sum is S. Let's call it T then. Oh, okay, my bad. It's S, not sum. Someone's talking. I don't think you can hear them. That's correct. I cannot hear anything.
hello?
Whoever was talking, you can talk again.
Can you hear me?
Yeah.
Okay, I just had a question about, so when you said then k plus 1 equals t plus 4, how did that prove that it's also sums of 4s and 5?
Because this is sum of 4s and 5s. And you add another 4, it still sums up and 4 and 5.
Oh, okay. Okay. I see. Thank
Because
you.
my T is sums of 4s and 5s.
Okay.
Or if you want to do what they are doing, you can also say this. So we know. So you can also say this, which is what the professors are doing. So you can write it as 4a plus 5b for some a b in integer union 0, right? Then k plus 1 equals to 4a plus 5b plus 4. Oops. So this is what they are doing, which is the same thing basically, which equals to 4 times a plus 1 plus 5b, which is also sum of 4s and 5s. You can do this as well, whichever way you want, which is sums of 4s and 5s. Whatever. Okay, leave it like this. 4b means you have a 4s and b 5s. Yeah, whichever way you like to write, you can do it whichever way you like. Okay. That's for this one. Let's do the next one. Let's do injective. Oh, I think I explained the same thing multiple times. We chose 4 because you want to write it as sums of 4s and 5s. You can pick 4 or 5, doesn't matter which one. I picked 4 because we can have less base cases. Because you want something that's in your IH. You want to use your IH. If you don't minus something, you can never get your IH. So you want a number that's smaller than this, but bigger than this. So you can use your IH. What do you mean? Strong induction is awesome. Induction is awesome. It makes your life much easier. A lot of hard proofs can. Oh my god, why minus? Because you want it to be less than k. You want it to be in this range. If you plus, then it's gonna go over. So you want to minus, so it's between this. Okay? Minus, so it's less than k. If you do plus, then it's not less than k, it's greater than k plus 1. You want it to be between 12 and k, so you can use a strong induction. Does that make sense? Sorry, I feel like I'm being so mean. N? There is no N. Where is your N? There is no N. There is no N here. Stop asking me the same question. I'm getting crazy. I'm actually getting crazy because I feel like I explained the same thing over and over and over and over again. Now you're just trolling me. I know you're just trolling now. Okay, move on. you know that you're wasting your own time, because the more time we're wasting, the less time I have to go over the next question, right? I mean, I'm not the one who's doing the quiz. I'm fine with doing quizzes, but I'm not sure about you. I'm not sure about you. I'm okay with doing any quizzes or tests. I love tests. I love quizzes. Injective, surjective, bijective. Come on, let's do this. Injective. Here, injective. Go back to my bad, terrible example. Injective means, well, this is your domain. This is your codomain. And they have some elements in there. Okay? Injective means you cannot have 2 elements for your domain mapped to the same element in codomain. So this is not allowed. For example, this is not allowed. Okay? They are fine, but 2 elements mapped to the same elements not allowed. So back to my terrible example, if those are, what did I use, guys or boys? Boys, okay. Girls are the domain, or girls are in the domain, okay. Well, it depends on if you want girls to be, it depends on if you want boys to be single or 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 girls to be single. Those are my boys. Okay, and they're dating. Injective means, what does injective means? Injective means we cannot have a boy dating more than one girl. That's what it means. You cannot have more than one girl, but your boys can be single. But they can be single. So you cannot have you cannot have two girlfriends, but some of them can be single. Okay, so that's injectivity. Surjectivity means that, so copy. Let's just put it here. So surjectivity, this is allowed. Now you can date more than one girl, you can date two girls. However, you cannot have a single boy. Means no single boys. So every guy in your codomain has to be dating someone. So in this case, it's not surjective. Because, well, this guy is single. Okay, no girlfriend. Okay, does that make sense? So this is surjective. So if you want something to be surjective, you want every single element in your codomain to be mapped. Does that make sense? And bijective means that, so bijective means that one exactly one girl is dating one guy, and so it's like, and exactly one guy is dating one girl. So everyone's loyal. I should just say everyone's loyal. So everyone's loyal and no one's single. It's like the perfect world. And no one's single. That's bijection. Like guy to guy, or you can have, this is just a dating show, remember? Dating show for straight people. You can have gay people, then those are gonna be boys as well. But in either way, everyone's loyal and no one's single. Yeah, dating show for straight people. I don't know, I can't find another way. Can't wait for the future 102 students to watch this. I mean, I used the same example in my previous videos as well, so people are watching. Oh, funny thing is, a PhD student, a really close friend of mine, he watched my video as like bedtime story. So so he watches my video as like bedtime story, basically just plays it. And one day he was playing the video, I used this example to explain injective, surjective, and bijective, and he laughed so hard. Then he called me immediately. He's like, yo, what did you just taught your student? And I was like, I told them it's a terrible example. I was like, I told them he's not watching 102 to sleep. It's more like for fun. It's like making fun of me. He watches my videos so he can make fun of me. He's a PhD, math PhD student, so he knows those stuff pretty well already. That's just okay. That's the explanation of injective, surjective. Now now we want to prove them. So how do I prove injectivity and surjectivity? For injective, this is what you use for proof. So when you prove injective, you suppose f of x1 equals to f of x2 for all x1, x2 in domain, and you need to show that x1 equals to x2. So this is what you use for the proof. And for surjective, you need to find, so for every y in your codomain, you need to find there is such an x in the domain for such that fx equals to y. So it's the same as the second half of your image proof. It's the same as the proof you really hate. The last time I used the dating show example. Okay, it's basically the same thing. That's why I said it's gonna come back to you. Here it comes. They're coming back to you. They're taking a revenge. There were like 102 students hating me. I'm gonna come back for you. So they're coming back for you. Basically the same thing. Okay. Now let's try this one. Example 4. I want you to prove that G is injective. How do we prove it's injective? Injective, injective, injective. Fun. Let's have fun. Okay, one of you suggests we have 2 cases for each pair, each part of the piecewise. That's correct. So what do I do? Proof. How do I start this? So I'm gonna let's say A, B in R. Then what's my first step? We have 2 cases. And I need to suppose G of A equals to G of B. Okay, what do I do next? And X, I don't have X here. There is no X. A and B less than 0, is that what you said? Less than or equal to 0? Okay, first case, if A, B are both less than or equal to 0, then we have A squared equals to B squared. What do I do next? How do I show A equals to B? Okay, square root them. So A absolute value of A equals to absolute value of B. And what do I do? So A equals to B. Why? Since A, B have the same sign, or A, B are both less than or equal to 0. What is my second case? Second case, if A, B greater than 0, then negative A equals to negative B, so A equals to B. Why do we not have other cases? Why do we only have those 2 cases? Why can one be positive, one be negative? Not because they are provided in the piecewise. There is another reason. Yes, because G of A cannot be G of B if one of them is positive and the other one is negative. Okay. So I'm gonna add one sentence here. We know A, B must have the same sign. Otherwise, G of A is not equal to G of B. Okay? Question? Why did I show absolute symbol? Because square root of A square equals to this. That's why. Question? What's an example of two inputs? What do you mean? What do you mean example of two inputs? Where you solve the other question? Where solve the other question? Huh? You mean this one? 3? I will post them very soon after your tutorial. Okay, so before you leave, I'm extremely worried about two variables. I'm extremely. Oh, can you explain why it's a contradiction if the signs are different? Because if A is negative, so A is negative, then G of X. So if A is less than or equal to 0, then G of X, G of A is greater than or equal to 0. B, if it's less than 0, then G of B is less than 0. No, greater than 0, sorry. If this is greater than 0, then you use this, so it's going to be less than 0. So those two will never be equal. Does that make sense? No. No, graph is not a proof, guys. Graph is not a proof. I want to do a question with two variables. Is that all for a proof? Yeah, that's everything for a proof. That's it. Should I do another one? Let's try this one. It's not hard, but I hope this can give you some idea of two variables one. So let's let f go from R to R, be a bijective function, and then prove the function, g, g go from R cross R, map to R Cartesian product R, defined by g of xy equals to fx fy is also a bijection. This is a question that might appear on the quiz. I don't know. I haven't seen your quiz yet. I don't know. I really don't know. Just doing something that I feel like you might not know. So how do I prove it's injective? Injective. No, it doesn't work like that. So let's suppose g of AB equals to g of xy, where AB, xy are from R to R. Okay, so what do I have next? Then what does this mean? This means that f of B equals to f of x, f of y, right? And then this means what? This means f of A equals to f of x, and f of B equals to f of y. Why? Why is this? Why are they equal? Why are they equal? No, I mean from this step to this step, why? Definition of Cartesian product, exactly. By definition of Cartesian product. That's what I was looking for. Okay, it's because the definition of Cartesian product, you know, those two are equal. Okay, now, you know, this will give you directly A equals to X and B equals to Y. This is because F is surjective. Huh? Why are you not letting me write? By the injectivity of F. Okay, so this will prove that G is injective. What about surjectivity? So I'm gonna pick, so let AB from R to R. How do we prove it? Yeah, but how do we prove it? How do we prove it's surjective? Suppose AB belongs to G. Okay, and what do we do next? So this is what you can do. This is what you can do. Since F is surjective, we know that there exists xy in real number such that f of x equals to A and f of y equals to B. So g of xy equals to f of x, f of y equals to AB. So G is surjective. Done. No, you don't assume A equals to B. A and B are not necessarily equal. Okay, zoom out. Yeah, I don't know. I think that's all I'm gonna do. There's not much I can do because every single question is different. There's not much I can do. You are on your own, basically. No one, there is no me to help you doing can help you doing your quiz. So no matter how many questions I go over, she can always give you a new one, which is different. You just need to use your brain. Use your brain, guys. Use your brain. Oh, this kind of composition function. Oh, specifically this one, sure, but they can just give you a specific F, you know? For question, they can just give you a specific. This is like a general case. Wait, Daria's here? Why is Daria here? Oh, why are you here, Dar?
I finished my class at like 2:55, so 5 minutes early. I went to Discord and people were talking with your tutorial, so I missed coming to your tutorial, so I joined.
Oh, yeah, I was just saying what's the possibility of their quiz video. I think they'll be given a 2-variable question. Yeah, anyway, back to my point. I think those two, they can give you a specific example. For example, I'll give you something like random example, by the way. Let's say 2x plus y and 3x plus 4y. And then I ask you to prove they're injective, something like that. You know, could happen. And also the question I covered before, like this, you know, like this could happen as well, you know? I feel like they're gonna give you 2-variable function because 1 variable is kind of too easy for you right now because you did many 1-variable ones. So if I were the professors, I wouldn't give you 1-variable function. I'll give you something involves Cartesian product. Yeah. And they love 2 variables. They love absolute value. they love absolute value. They love piecewise function. They love square root. Those are whatever you hate, they love it, basically. So whatever you hate the most, they love it. Probably because you hate it, so they wanna trigger you during your quiz. I'm just kidding. I'm just kidding. I'm kidding. They're not trying to do that. They're just trying to test your understanding. I said many things that are inappropriate as a TA. They are testing your understanding, not stupid. Yeah, so I think the same thing before quiz 2. Yeah, exactly. That's what I said. So remember, they like 2 variables. They love absolute value. They love square root. What else do they love? They love to combine things together. So everything you hate, they put them together. This course, I wouldn't say this, but for example, if you have calculus tests, then they love to put trigonometric functions there because people hate trig functions and inverse trig. People hate those, so they give you a lot. But for this course, it's mainly like absolute value, square root, 2 variables, something like this. when will this be uploaded? After, I don't know, after this tutorial ended. So I think we'll stop here. Trig, I've never, Daria, have you ever seen trig function in 102? I think I've never seen trig function in 102. It's
I think we
mostly,
had like once way back when everything was in person for a 1 mark question, but generally no.
yeah, generally, I don't think I've ever seen trig function in 102. It's mainly polynomials, absolute, square root. What am I eating? I ate a little bit. I don't feel like eating today. My boyfriend basically asked me, do you want to eat this? I was like, nah. Do you want to eat this? I was like, nah. He asked me so many, and I was like, no. And then eventually I was like, you know what? Just pick whatever you want. I don't really care. Example 2. Sure. Yeah, another thing is, I think I've seen exponential before. Logarithm as well as counterexamples. They use those a lot. Boyfriend reveal. I thought I did that last week, like when I showed my Instagram, has a few pictures of him. Yeah. So those like the inverse function of each other, arctan, e to the x long. Those we use those a lot. Okay. As counterexamples, what we would do. He was a TA, not anymore. He's working full-time at EY now. Well, that's too much information. He's working full-time now. Can I zoom out? Zoom out. Like this. Yeah, he was a TA, not anymore. Many of my friends are not TAs anymore. I feel like Daria's gonna be the one who's always gonna be there for 102. How many times has it been? 10 times? 11 times? For Daria? 10? Yeah, see, Daria TA'd 102 10 times already. She will stay here forever.
Yo, I don't know. When I start clerkship, I'll have 26-hour shifts. I don't know if I'll be able to teach that.
26 hours shift?
Yeah, we have 26-hour shifts, and yeah, it can go longer if you don't get out in time. Like if someone comes in, you might have to stay longer. So yeah, that's like next year. It's not in 5 years. My clerkship is next year. So who knows? I will try my best to stay.
26 hours shift. No 5 years of 102. I hope this is the first time and your last time taking this course. Yeah, this is a part where people say at the end of the semester, people say see you next semester, and I'm like, I hope I don't see you next semester, because I don't want to see my friends retaking the same course again. Like I'm glad to see you on campus or in other courses, but I don't really want to see you in this course, because I don't want you to retake this course. But I do see my students from previous semesters a lot.
Yo, people who say I am going to TA next semester though, don't misunderstand. I am not gonna stop, but I'm replying to the comment in the chat link. I'm too lazy to type.
How about you? How about me? About what? Oh, major? Me? Major?
No,
Math and chemistry.
They're asking if you're TA next semester, B.
I think that's a question for Tyler Holden, not me. Isn't it? You need to ask Tyler Holden.
I mean, I guess the question is, will you apply to it? You're
Oh,
definitely...
I did apply, but you know, I'm unit 3, so it's not guaranteed that he'll give me a position, because the students get priority, and I'm not the student anymore. And yeah, I minored in biology as well.
So math is a science, people, just so everyone knows. Okay, I
Now we're
think
just talking. I'm gonna stop recording because I don't want people to think we'll do anything math after. So stop recording and you